Alright guys, so in order to continue the series of the Java built-in functional interfaces, today's lesson will cover two interfaces from the Java util function package, and those are the function and BiFunction. So what is function and BiFunction, and when can we use them? Starting with the function, a function is a generic interface parameterized by one reference type in a return, t and r. It has one static method named identity, and it has two default methods, compose and them. This is what the function looks like. It has the function interface annotation. It is parameterized by the type t in a return. It has an abstract method named apply that receives a type t. It has a default compose method, a default and then method, and a static identity method. We will cover all of those methods in this course. Now let's talk about the BiFunction. The BiFunction is also a generic interface that is parameterized by two reference types in a return, t, u, and r. It has one static method, identity, also an abstract method named apply, but now receives the t in u, and it has one default method, and then. This is what the BiFunction looks like. It has the function interface annotation. It is parameterized by two types, t and u, in the return. It has an abstract method named apply that receives a type t and u, and a default and then method. So when to use the function and BiFunction? Let's take a look at some examples. It is used to combine arguments. It is used to produce a result. It is used to compose functions and also to chain functions. It can be used with lambdas and method reference as any functional interface. Let's take a look at some examples from the function and BiFunction. I usually like to show examples from the Java core library and also from the Spring framework. So let's take a look at some of them. Okay, so let's take a look at the hash map. You will notice that most of the Java core libraries will take advantage of the built-in function interfaces, and hash map is one of them. Let's get into the details of how the hash map uses the function and BiFunction. So this is the hash map from the Java core library. And we have this method computeIfAbsent that receives a mapping function. And take a look at the function that it passes. It passes a key and a value. Remember that the second type here is the return. And this is the key and the value of the mapping function, since we're talking about maps, right? And the mapping function will also have this apply. So depending on what you pass on your lambda, this will be the result, and the result is always the value. Okay, so the second parameter that we pass here. And let's take a look at the other. Now we have the compute if present. Okay, so if it is present, we pass the key, the value, and now it is a BiFunction, not a function anymore, it's a BiFunction. We have the key, the value, and we return the value. Okay, so with the remapping function, depending on what it does, okay, if it is null, then throw null pointer exception, but it will end up with the value, all right? So the remapping function that will be applied, we have the key, the old value, and then we produce the value here. Also the compute, in this hash map, there is a lot of places that receive the function and BiFunction. So this is the compute, not if present or if absent, it just computes and receives again a BiFunction. Okay, it cannot be null, so we will throw a null pointer exception, and this is the remapping function that at the end we will do a apply with the key in the old value, and the result will always be the old value. Annotation type mapping. So as usual, I like to present examples from the core Java library and also from the Spring framework. And from the Spring framework, let's take a look at the annotation type mapping. So this is the class annotation type mapping, and let's take a look at the method rEquivalent. See that it receives a BiFunction, which has a value structure. And even though we have a for loop in an old school way, it does receive the BiFunction, and it is applied whenever the method is found to be equivalent. Okay, so for this function example, I will create a function that receives a user object and returns a string of some type of concatenation. So we have this user object here that has just a pojo that has a age and name, and it has some auxiliary methods here, a user list creator, a static, a toString, and its getters and setters. Okay, so I'll start creating a static function that will receive this user and will return a string. Just call it func, and since we are talking about a user, and then I'll have a return. I'll just return anything here, just to be clear. Now I'll create a list of users, call it users, and I'll use the static method that I have, user list creator. All right, now what I want to do is get the username from this list and return the length of each one of these names. So for this, I will get the username and I will concatenate with the length. Nothing special here. And for this, I will transform to a string. For those who are familiar with Java 8, it should be by now. And I will map. You can see that map receives a function, so I will use this function here, right? So I'll have my user, and I'll use func.apply, and I'll pass this user, right? So let's just remember that this is the method. This is the main method that we want to use when we are using functions. And let's fix this a little bit. And for each one of them, I will print for each system out println. All right, let's see what happens here. Okay, so we have Bob, Lisa, Mohammed, and Andrew, and we can prettify this a little bit. So you can see that the IntelliJ is telling me that we can replace this with a lambda. So let's replace with a lambda. Let's clean this up. All right, much more readable. Let's see if it works. It works fine. Just to make it better, let's sort these names by their size. So let's use the sorted and the comparator.comparing string length. 3, 4, 6, 7. That's it. That's the first function example that we have. Now let's take a look at the compose and then methods from the function interface. So starting with the compose, a compose returns a composer function that first applies the code before function to its inputs and then applies this function to the result. All right, it's kind of difficult to understand this, but let's take a look at some examples of this. I will create a new function that receives a user and returns a user, right? And I'll call this func compose. And what I want to do here is actually add to the name of the person a last name, right? Just as an example. So I have the user dot set name, and I will get the name and concatenate a last name to all of them, right? And I will return the user. So why in this case I'm passing the user and returning the user? Because the compose method is applied before of the function that we have here. So if we do like this, func.compose, and I will pass my func compose, and then I apply my method. So first I will add the last name, and then I will apply my function here that retrieves the length of my method. So let's see if this works correctly. All right, now we have the last name for all of the names that we had, and it will print the length of all of them, of course with the compose applied before, but because now we are comparing all of the names with the length with the last name as well. And now let's take a look at the and then example. Okay, and then is pretty much the opposite. The and then function will be applied after we have the compose and after we have the apply. So let's create a new one. And since it is after we apply the function, we receive a string. And this is what we receive from the function. So in this case, we will have a string and return a string. And let's call this func and then. And now what I want to do here is just put an OK at the end, just for the sake of testing. I'll put an OK to all of them, right? So now I will compose. I will add the and then, func and then I will apply. Here we go. First we composed with the last name, then we applied the function that retrieved the length, and then we put an OK at the end, just for the sake of testing. Okay, let's now talk about the identity method. The identity method is a static method on the function interface. It is auto-defined as a method that returns a function that always returns its input argument. So what is an identity in mathematics? So the Wikipedia definition says that an identity is an equality that remains true even if you change all the variables that are used in that equality. In math, the identity function is one in which the output of the function is equal to its input. In Java, the function is a function interface whose identity method returns a function that always returns its input argument. Let's start with a very basic example, and let's create a function that has a string. Let's call it function, and it will do pretty much nothing. Okay, we receive something, return something. Let's duplicate. I will have function 1, function 2, and let's print the result of all of this. Function, duplicate, function 1 and function 2. Let's run, see what happens. Okay, you can notice that it has 3 different instances. So 3 different instances were created in this case. And now let's change this to function.identity, and let's do the same for all of them. And let's run this to see the results. Okay, so we have the same instance for all of them, same hash, same instance for all of them. So using the function identity, we can see that it has some advantages already. But let's go deeper on why the function identity is important in some cases. For the BiFunction example, I will create a map of users, and with a BiFunction, I'll print the key values counting the frequency in the case of duplicate names. I'll start creating a list of users. I'm creating this list like this using the user list creator because this method arrays.asList is immutable. So if I try to add something to this list, I'll get an exception. So that's why I'm creating the users like this. And for the users, I will add a new user, also Bob. So as we know, we have already a Bob here in this list. So what we want is to find the duplicates of this map. Now let's transform this list of users to a map. Collectors to map. And it receives a function, as you can see. So let's pass a user dot get name. Now we have a map. Let's create a local variable for this. Let's call it users map. And let's prettify this a little bit. There we go. Now let's create a BiFunction that receives the key and the value of the map and returns a string with the number of times the name repeats itself on the same map. So let's start with the BiFunction that receives an integer for the key, a string for the value of the map, and returns a string. Let's call it BiFunc. BiFunction is okay. And I will receive the key in the value. And for the key, the value, I want to print first the name, which is the value. Also the key, which is the age of the person, and how many times the same person is included on the map. For the number of times the same name is repeated on this map, let's use a method called collections.frequency, and let's pass the user's map dot values, and let's compare with the value that we have on this function. And now let's test. Let's do the user's map dot for each key and value. Let's print. I will move this down so it can be recognized by the program. And then I will pass the BiFunction dot apply. And here we go, let's test. Okay, we have Bob, 18, 2 times, Mohammed, Andrew, and Lisa just 1 time, and Bob 2 times again.